Everyone knows we have pothole problems. I mean, like I said before, I haven't met one single commissioner. Everyone's got a pothole problem, but none of them talk about the solutions to the problem. So I would say, especially if you're an elected official, why not, instead of just talking about the problem, why not say not only that, but we have a solution. It's not just a solution that's going to fix the pothole problems. Please look at mechanical concrete because you solve two problems with just one solution.
Even the optics of being in that position, it's a very a positive light to be under.
We would love to say Harris County is the first county in Texas to commit to building their roads like this, or, in South Texas. Give us a chance to build with mechanical concrete, and once they see it, they'll be convinced.
Welcome back to the Advisory As Solutions podcast, the show where we spotlight innovators, founders, and leaders who are building sustainable future of construction, infrastructure, and the built environment. Today's guest is someone whose work I believe deserves far more attention because it has the potential to fundamentally change how we build and maintain every road, parking lot, and surface across North America and beyond. I'm joined by Xan Difede, founder of Third Rock Renewables and the licensed marketer of a remarkable technology called mechanical concrete, a system that uses tire-derived cylinders to build roads that don't fail, they don't resist thaw, they support 80,000-pound loads and eliminate the pothole problem at the root. This is one of the innovations that is simple, elegant, and incredibly impactful, and I cannot wait for you all to hear this conversation. Xan, welcome to the show.
Thanks a lot, Jordan. It's nice to be here.
Xan, thank you so much for being here. We spoke briefly before the show, and something that stuck with me was just how passionate you are about this technology and how much of your personal story is actually woven into it. But before we get into the nuts and bolts of mechanical concrete, could you share a little bit about yourself and what led you into this world of renewables and waste to value innovations?
Yeah, absolutely. So living in Houston, it's pretty normal that or you have a pretty good chance of coming from an oil and gas background. My father was in oil and gas. My family's in oil and gas, and so I also grew up in the oil and gas, starting out in shipping and then moved into supply and trading. So I did the calculations. I think it's been around 37 or 38 years that I was in that type of role, and I owned a fuel supply and distribution company. And so I kind of saw the transition from just traditional fuels into more sustainable fuels, ethanol for gasoline, biofuels. And so I saw that transition and I knew it was out there, but it really wasn't a focus of mine. But then I had the chance to place some oil that was derived from a pyrolysis plant in Colorado. They were using tires as the feedstock, and you'd end up with a lot of carbon black, and you'd end up with some oil, and that oil was a great feedstock. And so they called on me and said, "Hey, can you help us place this oil?" Which I did. So as that was kind of unfolding, the opportunity came to me and said, "Oh, if you really want to help with tire placement or getting rid of end of life tires, I've got a great solution." And that's when it was actually a relative, a friend, a family member that came to me and said, "Look, there's this patented technology out there. I bought the patent in the company, and you like innovation. You're always looking for another project. So do you want to work with us on that?" And as soon as I heard about mechanical concrete, I immediately jumped on it and bought patents or the licensing agreements for the U.S., Canada, Virgin Islands, and Puerto Rico, because I'm not an engineer by trade, but when you hear about the technology, you don't really need to be because it's so simple that it just is very clear that this is the way we should be building roads and other surface areas. And so that's really how this all started. One thing led to the next. Um, I Ironically, I'm just now winding down my fuel company so that I can focus on this full time because I am really passionate about it, and I hope that when people see this, they'll understand why.
That's right. I can't wait to dive in a little bit more, and I absolutely love to hear about your transition. Okay, so for now, for those hearing this term for the first time, mechanical concrete, it might sound new, but the roots go back to a pretty important figure in American road building history, Sam Bonasso, right? A
Yeah,
federal DOT director of innovation under President George W. Bush. Is that correct?
yeah, correct.
Okay. Could you maybe walk us through a little bit more of that story?
Yeah, so I haven't met Sam Bonasso yet. I hope to get to meet him someday. But what I have heard about him is he had kind of had the idea of mechanical concrete for a while, but then he was also the Secretary of Transportation for the West Virginia DOT. Then he went on to serve under George W. Bush, um, President Bush, for like you had said, the Innovation Division. So he was the Deputy Administrator for Research and Development, which included innovation. I think they've changed titles since then. But then after he served his 4 years, he went back to West Virginia, and he started working on mechanical concrete. And he came up with the name because typically concrete would be a chemical reaction. So rather than getting the strength of concrete from actually cement, you get the same strength from a tire derived cylinder, which is exactly what it sounds like. A tire that's at end of life would normally have the sidewalls removed in some states. Every state has its own regulations. In Texas, where I'm from, the sidewalls need to be removed. So at that point, it'll go to a recycler and they'll shred it. They may take the steel out and burn it. But what we do is we take that same cylinder, which is on average about 9 inches deep, and we use that as a cylinder confinement technology. And so if you think about it, when a traditional road is built, they'll compact typically limestone or whatever their natural stone is. They'll compact that. They'll use water and wet it down, and they'll build their lifts until they get the base as deep as they want it, considering whatever weight vehicles are going to be using it. Instead, we only need 9 inches, which is the depth of the car tire. So the first question that we get is, are you shredding the tire? We don't shred the tire. The sidewalls are removed. That may be sent to a shredder to use in playgrounds or sports fields. We want the cylinder. So we have this cylinder, and they're just laid out in a very simple honeycomb pattern. It doesn't have to be perfect. They're tacked together to stay in place. And as soon as the aggregate is placed inside the cylinders, you have a surface that you can drive 80,000-pound trucks over. So it doesn't have to be perfect, but it's just the fact that the aggregate is confined to a cylinder. So a traditional road base doesn't have any type of confinement. So whenever that base gets wet, which is going to happen even if you have an asphalt surface because water will leach up from underneath, as soon as it gets wet and you have a heavy vehicle driving over it, and that could be even a garbage truck or a cement truck coming to lay a new home or something like that. When it drives over it, it will push down and that base will push out and you'll form a pothole. So if you think about it, if that rock is inside a cylinder and weight pushes down, there's no way it's not physically possible to form a pothole. And it's really that simple technology of cylinder confinement that is the whole technology that surrounds mechanical concrete. So when we say it's really that simple, it really is. It's just cylinders, tire cylinders, steel belted, so the steel's left in place, and we use that to put aggregate in so that it can't shift out and make a pothole. So roads built with mechanical concrete or even surface areas, parking lots, will never form a pothole. There's never, I should add, some of these roads are about 15 years old and they have still never formed one single pothole. There's an example of a road in West Virginia, one of the original roads built that gets about 350, 80,000-pound trucks a day over it, and they've never fixed that road.
That's still amazing to me. Like we talked about in our pre-call conversation, how 15 years of heavy usage, industrial usage, and not a single pothole. And I think that's really where the magic of innovation really comes from. It's the simplicity in it, and it's actually usable.
It is the most innovative or the simplest way to use end of life tires. There's no extra resources used to take the steel out, and it builds something that's basically indestructible. And there are other types of cylinder confinement technologies, but they're man-made, so they're made from plastic. They can break. They're harder to use. It's harder to get your aggregate down into the cylinders. And there's nothing stronger than a steel belted radial tire to use for cylinder confinement.
Right, right. Okay, yeah. So as you mentioned, a ton of benefits. All right. Then another thing we also discuss is, and what I love about this as well, is this ripple effect is you guys are not just building stronger roads. You guys are diverting tens of thousands of tires per acre away from landfills. You're eliminating, or at least decreasing a massive amount of water usage, as well as reducing excavation. You're cutting CO2 from repeated repair cycles. Could you walk our listeners through the environmental and carbon effects of that?
Sure, you did actually a great job just now. So I'll recap that and maybe add a few things to it because it is a really long list. Watchers, if people that are watching this go to the website, it's more clearly line itemed out. But the big one is diversion from landfill. So just as you had mentioned, every acre takes about 10,000 tires away from a landfill. When I say away, the right word is probably diverted. So we divert about 10,000 tires from a local landfill. And every state is different, as I mentioned, as far as their regulations. But what we want is the cylinder. And so 10,000 tires per acre are diverted from landfill. And there's was a job recently done in Georgia, and that I think that took about 4,000 tires away from a local landfill there. So the goal is to burn less tires, send less tires to landfill. They last 100 years in the landfill. If you want the numbers, they're pretty astounding. The U.S. generates, and when I say generate, I mean coming in on new cars, new tires coming in, from foreign manufacturers, and then tires that are built in the U.S. or manufactured in the U.S. That's about a million a day, and that number is really hard to wrap your head around. About 60 million a year are sent to landfills. So that's the number that we want to reduce. We want to reduce the landfills. And the best place to put a tire is underground, out of the ozone, out of UV. And so we solve the problem of, by diverting from landfill, we're still putting tires underground, but we're making beneficial use of those tires. And then the other benefits that you mentioned, it's a really big benefit. Water is a huge natural resource. We don't need water to build with mechanical concrete. So that normal compaction that you would do with water in a traditional build doesn't happen with mechanical concrete. There's no curing time, so it's a faster build. Um, Depending on what your sub base is, if you have a soft sub base, we have a lot of that here in Texas. You may want to lay a geosynthetic liner down just so that your stone isn't pushed down into your soft caliche base or whatever your soil is underneath. So you're saving on your water. You use your natural stone, which in the Houston area we have literally mountains of crushed concrete, and we can use crushed concrete. So there's another recycled product going into into a renewable product, which is huge. You cut about 75%, at least 75% less expensive on your maintenance because you're not going to be coming out and fixing those potholes again. And then there's all the ripple effect that goes with that. No additional asphalt, no additional water, no more labor coming out. And then the value of not having to close a road down, not having workers out on the freeways or out on the roads, and it just continues. The benefits just continue. We have Rice University's working on a carbon credit model for us right now. And it's taken a while because there's sort of the first round of savings, and then there's the second round just by not having to come out and fix the roads over and over again. So there's the benefits just continue to go on and on. The biggest ones being water and using your natural resources.
Right. I can only imagine how impactful as you guys just, continue to grow and scale, how impactful these savings and reductions in emissions will actually make.
Yeah, so that's part of the RISE study right now is just like how much of CO2 emissions are reduced, by not doing the continued maintenance and things like that. So they're still, turning over, more and more savings, and so hopefully we get that wrapped up soon. But it's what is so great about it is, we always get the question of what's the best application for it, and literally any build where you're gonna have any type of weight bearing load go over that road or that parking area is a perfect application. It could be these massive warehouses that you see everywhere. Those are constantly going to have tractor trailers, rolling over them. A subdivision that you're putting in new roads. The first thought is, well, but that's not going to have a lot of trucks going over it. But it only takes one 80,000 pound truck, which could be a tractor trailer coming in to, or a cement truck coming in to lay a driveway. You're going to get base failure, and then once you get the base failure, you're not going to be able to fix that. You can keep throwing asphalt over it, but you're not going to fix that pothole. It's going to keep coming back. So there's industrial applications, truck yards, docks and wharfs. You can use it for retaining walls. You can use it. One of the jobs that we're doing here in South Texas is just a road that gets a lot of, it's kind of on a turn, and so it just gets a lot of extra weight pushed down on that area. And so they're just going to cut this section out and just do a repair for that one section as a trial. So the best bang for the buck is going to be a new build because you're excavating anyway. But if you have a section of a road or parking lot that you're consistently having to repair, then we can cut that out, or the civil engineer or the contractors would cut that out, and then we would come in and lay the cylinders down, and then they wouldn't have to fix that again.
Yeah, I just love the versatility and the many use cases for your guys' system. Okay, so Zen, now here's the part I think people need to hear. For something that works so well, something that's tested, it's something that's extremely cost effective. You told me it's also the hardest thing you've ever sold. Why is that?
There's a couple of reasons. I haven't met anybody that says this is terrible or didn't say, "Hey, can you come to my town?" Everybody will thinks they have the worst roads. I think we do. So everybody thinks they have the worst roads. But I think one of the challenges is when you're talking about construction, everything is laid out so far in advance. And so you've already got, anything that's being built right now was, budgeted last year or earlier in the year. And so you have to get ahead of that, and then there's just the reluctance to change. And we've built roads like this, and the first reaction is, yeah, but they're not working. Why do you keep building the same way if you're repairing them? But you know people are reluctant to change, and I think a lot of people are worried about sticking their necks out. What if this doesn't work? And that's why mechanical concrete is so great, because we're not looking for anybody to come in and try this for us. We already know it works. These roads are actually, some of them are close to 16 or 17 years old now and have still never had repairs. But someone's got to step up and say, okay, we've had enough. We're not going to fix this road anymore. We're going to fix it the right way, and we're gonna build our roads like this going forward. And so the couple of projects that we have on the books right now are both county jobs where the commissioners have come in and said, "Okay." Well, the commissioners or their directors of their road and bridge that are tired of fixing the roads have gone to the commissioners and say, "Okay, we're repairing these same sections of road, every year." And they've been in agreement to go ahead and use mechanical concrete in that area. And in both cases, they have said that, if this works, and we know it will, we've got we've got a lot more sections that we wanna repair this. One of them is, I'm in Houston. It's a really big deal for us, but Harris County, one of the precincts has agreed to a test area. They're calling it a test because it's their first section, but I know they're gonna love it, and I'm just looking forward to doing that section for them because we know there's a lot more to come.
That's exciting. Then, okay, so it does sound like the tide is turning. And you had also mentioned you guys have had some major wins as of recently as well. Do you mind sharing a couple of those?
Well, those are a couple of the wins that I was talking about. Was the job for Harris County. We have one for Hidalgo County in South Texas, and then the patent owner actually did a fairly significant job in Georgia, in Meriwether, Georgia, and the county commissioner there absolutely loves mechanical concrete. They have thousands of miles of rural road there, and they've never used any type of stabilization for the base. And they get a lot of rain, and it's just nonstop trying to fix these rural roads out to people's residents. And so they did this one section, and they got 10 inches of rain the next day, and the road is still perfect. And in that situation, I think they topped it with milled asphalt, which is another recycled product, and they love it. And I know that the patent owner said I think they just received another job in the same county that's going to take another 4,000 tires, divert from landfill 4,000 tires for this new section. And I don't think there's an end in sight there. I think they're just going to continue to fix their roads and build their new roads with mechanical concrete.
That's fascinating. Okay, Zed, here's one thing. You touched on it very briefly, but that kind of floored me. was when you said mechanical concrete, it can actually rebuild a road or emergency bypasses in 6 hours, like even after a hurricane. Can you walk us through that scenario?
Yeah, so one of the benefits of mechanical concrete is that it's a quick build. And a traditional road, you're laying these lifts and they have to cure and you do the next lift. Mechanical concrete is instant. As soon as the cylinders are laid down, and so you can envision, if you go to the website, you'll see it. But these cylinders are laid out and tacked together in a honeycomb pattern, and as soon as the stone is put in, it's completely drivable. So depending on the length of the section and the number of workers that are on the section, you can really do it in a few hours. I wanna say, the patent owner laid 3,500 tires in something like 4 or 5 hours. That's a massive section. That's much larger than a bypass road would be. If you get a washout and you just need to be able to get around it, or a power line has a problem and you need to get an access road to a power line, we can lay a liner and we can get the cylinders out, tack them together, and have aggregate in it literally in maybe 6 to 8 hours if we have the resources on hand. And to be able to, not just a road for car traffic, these are roads that can hold emergency vehicles. So if we lose a road and we need to get emergency vehicles somewhere, where we don't have road access, we could do that in a really short amount of time. And um, it hasn't been used in that application because we haven't had it set up in advance. But it is something that we really want to pursue because living down along the Gulf Coast or even the East Coast, there's we always have potential for storms, and there's always issues with getting emergency vehicles into remote areas, and this is something that could be used for that.
Right, and you mentioned you guys also have the license and patent in Puerto Rico as well, right?
We do, yes, and they have a lot of the same issues, obviously, but also, just with the terrain, they have a hard time getting access to power lines, and so there's a project now that, we have someone working on down there to see if we can use mechanical concrete in order to lay some maintenance, pathways into the power lines.
Wow, that's just incredible. Potentially life saving at times as well. To implement this technology to of course save time and then provide that accessibility.
Yeah, and especially when you start talking about the islands, Puerto Rico, we have the Virgin Islands also. They have terrible roads. We have family members that actually live in Puerto Rico and in the Virgin Islands, and the roads are just bad. And you know how we pay our tire disposal fee? They pay at a minimum of $20 a tire in the islands because those tires have to come back to the US for disposal. And for them to be able to use their own cylinders at the end of life for these tires to build better roads is a really big deal. And the other thing that we really didn't talk about, but you don't need any specialized equipment, no special tools, just a $99 tack gun that I grabbed some on my way down here for this project. And then you just need labor. You really do just need the manpower, and it's just physical. It's just laying the tires in place and then using a front end loader or whatever equipment you have to push the aggregate into the cylinders. And at that point, you have a completely usable road. And it's important because we haven't really discussed this, but what we're replacing is the base, not the wear surface. Now you could put more aggregate on it, and you could just have an aggregate road, a rural road, but the alternative is that you put your asphalt on top of that, so you could have 2 or 3 inches of asphalt on top of that, and that's the majority of what we see is mechanical concrete going under asphalt roads because of the constant pothole repairs. But again, we're just the base. We're gonna give you a base that's not gonna fail regardless of a concrete, an asphalt, or just an aggregate wear surface.
That's terrific. Okay, then if you could speak directly to the decision makers, whether they are county engineers, DOT officials, maybe infrastructure planners, what would be your core message to them? Like, how would that help them rethink how we build roads?
So I think it would be maybe, everyone knows we have pothole problems. I mean, like I said before, and I haven't met one single commissioner or senators. I've met senators in Washington State, and they all everyone's got a pothole problem, but none of them. talk about the solutions to the problem, especially when you get around election times. And you'll hear a lot about roads and potholes and all these problems, but you don't hear very much talk about how they're going to fix the problems and how they're going to stop the problems from happening in the future. I know one of the towns near us had an app. You could load the app up and take a picture of all the potholes, and there was some prize at the end. But there was nothing about what they're going to do to actually fix those problems. So I would say, especially if you're an elected official, why not, instead of just talking about the problem, why not say not only that, but we have a solution. It's not just a solution that's going to fix the pothole problems, but we're going to take 10,000 tires away from our local landfill. There's costs associated with that as well. I mean, that's another savings that's part of that the total savings for the project. But we're going to fix your pothole problems, but we're also going to divert tires from our local landfill. And regardless of what side you're on, whether you're worried about potholes or whether you're worried about the tire problems, it doesn't matter because you're going to fix your problem and you're going to get this bonus because you're going to get a pothole free road or you're going to get your tires diverted from a landfill. So for me, I would say for the mayors, the senators, county commissioners, anybody that's in a decision making role, please look at mechanical concrete because you solve two problems with just one solution.
Right. Even the optics of, being in that position, it's a very, a positive light to be under.
Yeah. We would love to say, Harris County is the first county in Texas to commit to building their roads like this, or, in South Texas, any county, any state that makes a commitment to maybe not in every application, but, in any application where it makes sense, you know, give us a chance to build with mechanical concrete. And once they see it, they'll be convinced. So Guadalupe County, we built a road. I didn't build it, but it was built about 15 years ago in Seguin, and the county commissioner says that it's still the best road in the county. And you can see where the mechanical concrete is. They haven't even you can start seeing the cylinders come through as the asphalt's been worn off. And then on both other ends of that section, there's nonstop pothole repairs. And so they'll tell you this is the best section of road in the county. So we know it works. There was a pause, and we didn't really talk about it, but San Benito actually got an illness and was unable to continue to market the product. So there was a gap of maybe about 8 years where he had built up momentum. Some of the border wall in Arizona is built with mechanical concrete. California has construction projects. West Virginia, Ohio, Texas. There's a few other states that have projects that have been completed, but then after, Sam got sick, then the momentum just kind of fell off, and so the one of the challenges that we were talking about was actually getting it back in front of people. We get asked, "Why haven't I heard about it if it's so great?" Well, it's because it hasn't been marketed for this huge gap, and a lot's happened in the last 8 years. We're more aware of sustainability. We have, you know how many billions more tires that we've generated during that time. And so it's a good time now to get back in front of it and start building our roads or doing our maintenance with mechanical concrete.
I love it. Super excited. I love how you're able to literally feel where the road stops and the mechanical concrete starts.
Yeah, and actually, when you say you can feel it, you actually can because you'll hear the sound, and then when you get to the mechanical concrete, it is a smoother sound, and it's just from the cylinders there, and one of the other things, and you actually brought it up, but I didn't really touch on it, but the northern states are very affected by freeze and thaws, and we did a project in one of the northern states, and it was a transload site for petroleum products, and they were always having problems because they were just using aggregate without any confinement. And we did one half of this circular loop with mechanical concrete and the other half without. And halfway through the winter, they were already bringing in more aggregate on the side that was built traditionally. It was nonstop repairs, and on our website, you'll see both sides of it, and the side with mechanical concrete is completely perfect. It looks like the day we left, and this is after going through the freeze and thaws, which is a really big problem for the northern states that are really affected by that. I have an app for bids that are coming out constantly, And the northern states, every day I'll probably get 50 or 60 bid packages come out where they're doing pothole repairs in states up in the Northeast. And all I can think about is, gosh, I wish they were building with mechanical concrete because we wouldn't see that road come up ever again needing pothole repairs. We know it's a product that we need up in the northern states.
That's yeah, 100%. It's something that we need everywhere. Let's get these tires out of the landfills and let's build better roads that require way less maintenance. And as we mentioned, that ripple effect just continues on. Okay, so Zen, it's clear you are passionate about the environment. You're an innovator. You're an entrepreneur. Now, I just wanted to kind of touch on something that you'd shared in regards to your biochar work.
Right. So, I had mentioned earlier, one conversation leads to the next and the next. And so I crossed paths with someone that was big into paralysis, but it was of different products. It was of more like woody mass or different types of feedstocks. And the product that comes out of that is biochar. And it's been around for a while, but not a lot of people talk about it. But I've learned more about it. It's a fascinating product. It's extremely porous, one of the most porous products on earth. It ends up like a charcoal, it can either be pelletized, into pellets, or it can be left as a powder. But it actually sequesters CO2, methane, PFAS, metals, all kinds of hydrocarbons, and it just holds that. Anything that's been leached, it just holds that into the pores and doesn't let go. It also restores nutrients to soil. It helps water retention in soil. We have a couple of patents of different types of products to actually hold the biochar in place, but it can also be sold in 2-ton super sacks or different size packaging. And we're just kicking that off. So it's something to watch for. It's actually part of another company that I'm an owner of. We're really just starting to work with it now. And then Third Rock Renewable, as I market it through Third Rock Renewable also, just because I have a different group of clients that were just familiar with Third Rock Renewable, and so we market that product under Third Rock also. But it's really exciting if you look up biochar and the benefits of it. It's a very long list of benefits. It's pretty amazing.
Well, I'm very excited to see where that leads as well. Maybe that's another episode. I'd love to have you guys on. What's to see your guys' development, your guys' progression, and in 2026, perhaps.
Yeah, that would be great. Some of it's I'm under an NDA, so you can tell I'm kind of being careful about what I say, but we are really excited about that. I think probably in 2026 we'll be able to talk about it a little bit more, and I'll have some maybe an update on the status of some of the products that we're going to be marketing.
Okay, okay. So aside from that, then, just for our listeners, then, and from your expert background, what's one trend in construction or even infrastructure that excites you or that you're excited coming down the pipe?
Although we don't hear a whole lot about sustainability right now, it's kind of put on the back burner. I think that that will change, and we do see a lot of companies that, even though maybe they're not really pushed to be as much maybe not as much environmentally sensitive right now, I think they look beyond that and they're continuing to make investments and use products that are sustainable. And yeah, I talk to people all the time that say, yeah, we're going to continue to push building green, and that is very encouraging. And so we think that we'll continue this growth, and that we'll have more and more people, calling for mechanical concrete. And I'm really thankful that you had me on this podcast because it really is about getting the word out. And it you have to be able to get to the decision makers, and this is a great platform to do that on. So I appreciate you having me here today because that is just gonna be really huge in helping me get the word out on this. And I think that if we can get to the right companies, there's some huge tech companies, some huge warehouse. You'll know who I'm talking about. I've met with their construction companies a couple of times, and they're interested in maybe putting mechanical concrete in their next rounds of warehouse batches. And those types of companies, I think, not only do they see the benefit of not having to fix the roads again, but they're looking at the amount of emissions that they're putting out, and I think they see the benefit of being able to offset that with some CO2 reductions in their building. And so I think the fact that these types of companies are still looking for sustainable options is really encouraging.
Absolutely. I couldn't agree more. And no, Zan, it's absolutely a pleasure to have you. Um, but before we wind things down, where can our listeners find you, find Third Rock Renewables? Feel free to drop any websites, any socials.
Yeah, sure. So our website, which is the best place to go, is www.thirdrockrenewables.com, and it's the number three, so 3RD, thirdrockrenewables.com. And there's a quick 3-minute video link on the website. And it really is the best way to get a 3-minute recap of mechanical concrete because it's ironic. So many people look at the video and they're like, I'm glad I watched that because I really thought I knew what it was, but I had no idea until I watched the video. Because some people will still think that we're shredding tires. And we're not shredding tires at all. We're doing the opposite. We're keeping it intact, less surface area exposure, but not shredding tires. And so if you can go to the website and watch the video, I think it really helps understand the whole concept. And it shows how really simple it is.
Terrific. Well, I'll definitely post the website in our links below. Last but not least is kind of my favorite part of it. If you could leave our listeners with one message or maybe one challenge for them to live a more sustainable, more environmentally friendly life, that they can implement today or this week, what would that be, Zen?
Probably just I think as a taxpayer, without getting too political, as a taxpayer, you do have a voice, and I think you have a chance to say that you live in this town and you want this town to look at this. And we're working, this is what's happening in Alabama right now. We have a woman there that's just really passionate about it. And the squeaky wheel in that case does get the grease because we've been able to make some progress there. But I would say, think about, the numbers are that for every individual, you go through one tire a year. Do the math on that and realize that 100 years per tire, we have to do something besides what we're doing right now. We can't continue to burn all the tires and we can't continue to go to landfill with them. So just think about that and maybe even, where you live, is there an opportunity for you to say, "Hey, have you seen this technology? Take a look at this," because it really might be that simple, just spreading the word that this is available and that it really does work.
That's wonderful. I love that challenge, and I hope our listeners take a lot of value out of this entire conversation. Zen, it's been brilliant, and I'm genuinely inspired by what you're doing. For everyone listening, if you want stronger roads, safer roads, greener construction, and a way to eliminate potholes permanently, go learn about mechanical concrete at Third Rock Renewables. And Zen, thank you for your leadership, for your passion, and for helping reshaping the way we think about infrastructure.
Thank you so much, Jordan. I really appreciate it, and for you to give me the chance to talk about mechanical concrete. I'm looking forward to our next opportunity to talk again in 2026.
I am as well. And if you guys have enjoyed this episode, please like, comment, and share. It helps us get the message out and support innovators like Zan and Third Rock who are making a real impact. Subscribe to us on YouTube, LinkedIn, and wherever you get your podcasts. And until next time, I'm Jordan Salvador, and this is the Advisor AI Solutions Podcast. And until next time, automate the ordinary and scale the extraordinary. Peace.